So let's talk about odd degree and even degree. They're two different categories. Nothing else can happen in polynomial functions. They can have degree 1, which is linear, forget about that. They can have degree 3, degree 5, degree 7, and so on and so forth. Or even quadratic, we already discussed that. So 4, 6, 8, so on and so forth. Nothing else can happen. These are the only two possibilities. For an odd degree, the function has two possibilities based on the leading coefficient. Like the linear function has two possibilities based on the leading coefficient. Like the quadratic function has two possibilities based on the leading coefficient. So if the leading coefficient is positive, if you remember, the linear function is increasing from left to right. And so will any polynomial function coming from negative infinity and going to positive infinity. And that is carved in stone. Now, if the leading coefficient is negative, of course we remember, then the linear function, which will belong to this category, will look like this, coming from positive infinity and going to negative infinity. Of course it has the odd degree can have more than one term. Okay, it's possible. So the same thing here, I don't know how many terms, but it's coming from positive infinity and going to negative infinity. You will find it in your book. I don't like to say that. Rises left, falls down, falls right, whatever. It's the same thing with the linear function. If the slope is positive, it looks like this. If the slope is negative, it looks like this. You don't have to say falls right, rises left, and stuff like that. But it's up to you. So it doesn't matter to me. Same thing here, right? So this was the linear function, right? Either this or this. Here, we're going to think in terms of quadratic function. This one with a positive leading coefficient and this one with a negative leading coefficient. So if the leading coefficient is positive, whatever, I don't know how many terms it has, but it comes from positive infinity and goes to positive infinity, like this one with a positive leading coefficient. If the leading coefficient is negative, it will look like this. But I don't know how many terms it has. We'll talk about terms in a minute. But it's coming from negative infinity, does whatever, and then goes back to negative infinity. This is it. There are no other options when it comes to something that is called end behavior. I'll remind you of that when I list everything. Okay. The other thing that we have to think or talk about before we even look at one graph or the first graph is what it's called multiplicities of x-intercepts. Multiplicities of x-intercepts. What is that? Okay, so we solved, that's why I kept this, that's one of the reasons. We solved, among all these 8, we solved polynomial equations, degree 3 or more. This was sometime in September, I think. Okay, so if, let's say, I have the equation x cubed equals 0, we know the degree of this polynomial. Can anyone give us the degree of this polynomial?
3.
Exactly. How many solutions do you expect?
3.
Exactly. But look what happens. When I solve this equation, I do have 3 solutions, but it happens that all of them are identical. Because 0 as a solution appears, it's identical, appears 1, 2, 3, we will say multiplicity 3 for x equals 0. And I'm sure you are asking yourselves, that's beautiful, but what does it mean? In a moment, I'll get to it. So this function, I could say it crosses at 0 3 times. That's not possible. It only crosses once. It's just that the solution, identical solution, appears 3 times. How does this translate into the graph? How does this affect the graph? This is what is important. That's why I need to know the multiplicities, because they have an impact on the graph of the function. Okay, how? Let's see how. Let me push this device further back. Okay. So how does this, the idea of multiplicities, how does it affect the graph? Here it is. We graphed x cubed several times for many reasons. And here was the graph. How come that I graphed it kind of flat? How come that I didn't graph it like this? Just across. Well, because 3 solutions x equals 0. That makes it flat. Flat cross, or a cross that is flat of the x-axis. This one is a straight cross. So here, this will be y equals x, because y equals 0 or x equals 0, in other words, multiplicity 1. Multiplicity 1 will cross straight, either from below the x-axis to the positive side, or from the positive side to the under the x-axis. So for odd multiplicities, this has nothing to do with the degree that is odd. This only says that a solution appears once, 3 times, 5 times, 7 times, blah, blah, blah. Okay, so here is what happens with odd multiplicities. A function that has a solution, an x-intercept that appears once. This is one cross, straight cross over the x-axis, multiplicity 1. And it can be this way as well. Here is a flat cross. Still crosses only once, but it takes its time. This, whatever that is, let's say x equals 4, has multiplicity 3. It's a cross. They all of crosses, they're all crossing. All. For odd multiplicity, they will always cross the x-axis, always. And here's one with, let's say, see, this one takes even longer. It's only one intercept. But this the multiplicity of this solution, I'm going to pick a number, x equals 10, is 5. The higher the multiplicity, the flatter the cross is. Still only once, but flat. Okay, enough of that. Let's move on to the even multiplicity. What do you think will happen with the even multiplicity? If a solution appears twice, 4 times, 6 times, etc. Will it be a cross, or it will be something else? It cannot be a cross. It will always be a term. So here are examples. This is our familiar case. Multiplicity 2. Here's another. See the difference between these two? This is fast in turning, and this one takes its time. So obviously this is a multiplicity 4. And here's another. Still one cross, one intercept, but this intercept appears 6 times. Okay, now we are ready, having all this information, having the behavior, this is the behavior of the function, I'll mention that again, knowing the multiplicities or what they mean and how we get them, we are ready to graph any polynomial function of any degree. And then I'll tell you where to pick from, and if you'd like to pick, I'm looking at the page. So, okay. If you'd like to open on page, I'm getting there. I'm looking at 371, not yet. 370, you can put it up there so you don't have to go page by page. I'll tell you in a minute. It's a long section. It just, they explain and explain and explain and explain. Okay, finally, I got it. Okay, if you'd like to open on page 378, I will choose the first one and you will choose the next. Okay, I would like to start with 49. We have f of x. Negative 2x to the 4th plus 4x cubed. We are asked to graph. Before we even start, now we are ready to list. So I'm going to write graphing a polynomial function. This is the list of items that we have to go through. 1, domain. 2, not necessarily in this order. 2, x-intercept. 3, y-intercept. 4, end behavior. The end behavior is exactly what we discussed. This is where it's going. What are the ends? What are the ends? The end behavior. I want to go back here, which is extremely important. And multiplicities. So the x-intercepts and their multiplicities. 5, degree. 6, number of possible turns. 7, by turns we mean max, points of max, local min. 7, actual max or min. In this class, we will not be able to do this without the calculator, so I will put in parentheses TI-84. It can be 83, it can be 81, whatever you have, but we have to use a graphing calculator. And 8, I would like to add range if possible. Okay. So I will start, of course, with a degree for this function. I'm going to copy it. Negative 2x to the 4th plus 4x cubed. And I will check them off the list. This list will be given to you. I will ask you to use this list to present everything. Okay. So can anyone give us a degree of this function?
4.
Thank you very much. The degree is indeed 4, which means we have to find, so this is done, how many x-intercepts do I have to find?
4.
4 solutions of the equation f of x equals 0. In other words, 4x intersects. Perfect? Good. So I'm doing number 2. So this was the degree first. And then in number 2, I write the equation, negative 2x to the 4th plus 4x cubed equals 0. We know, because it's on our list, how to solve this. What do we have to do first? What would you recommend? What would you recommend to do first?
I would take out 2x to the third, something like that.
Okay, a note. Never divide, oops, I'll re-erase that. Maybe I can make up. Never divide by the variable. If you meant to pull it out, I would have to agree. And I think that's what you meant. So, but I'm not going to start with that. I'm going to absolutely divide by negative 2. First of all, I refuse to solve an equation with a negative leading coefficient. And secondly, dividing both sides by 2 will not change the solution. So I will divide both sides by 2 to simplify. So then I have x to the 4th minus 2x cubed equals 0. At this point, absolutely yes, I completely agree. I will factor out x cubed, and I get x minus 2 equals 0. And I need to find 4 solutions. Can anyone give us those 4 solutions?
2 and 3 zeros.
Very good. X equals 2. X equals 0. Awesome. What is the multiplicity of x equals 2?
1.
Very good. Awesome. Which means it crosses normally at that point. At that x-intercept, it crosses normally. Good. Next one.
2.
Careful.
3.
Yes. Because 1 plus 3 must equal the degree. If the degree is 4, make sure that the multiplicities all add up to 4. If they don't add up to 4, something is wrong somewhere. Good. So this is a cross. So cross is here, but not normally. Flat. Slowly, if you want. I don't know how you want to put it in writing. It doesn't matter to me. But it is crossing slowly. I am on another device uploading a class from yesterday because my internet didn't work. So I'm sorry, I'm multitasking because if I don't do it before I reach my limit of the capacity of the computer, I will not be able to record your video. So that's why I have to be careful here. Sorry, my apologies. Good. Excellent. So what we have so far is x-intercepts done, degree done. I would like to identify now the number of possible turns. Okay. So, and there is a recipe for that. Number of possible turns is always degree minus 1. In our case is 4 minus 1, so 3 is the max possible number of turns. It doesn't mean that the function has to turn 3 times. It only means it cannot turn more than 3 times. But it doesn't have to turn 3 times. Any questions?